Okay, so this is just a recording of the electricity review. An electric potential of 1 joule per coulomb is equal to, so a joule is energy. Sorry, let me get the thing. A joule is energy, and a coulomb is a charge, so it'd be E over Q. And if you remember, that is a volt, so of 1 volt. All right. Next up, we skipped, I think, 2, 3, and 4. So then we've got two charges are a meter apart, and they attract each other with a force of 2 times 10 to the negative 5th newtons. If the distance between the charges decreases to 1 meter, the force of repulsion would be. So it's 1 times 1 times 1 divided by 1/2. Why 1/2? Well, we're going from 2 meters to 1 meter, and 1 meter is half of 2 meters. But remember, you have to square that, and so that means the force would go up by a factor of 4. And so 2 times 10 to the negative 5th times 4 is 8 times 10 to the negative 5th, which is C. Number 6, as shown in the diagram, a neutral pith ball suspended on a string will attract to a positively charged rod. During contact, the pith ball will, well, since the rod is positive, that means that the pith ball has to be negative. And since protons can't move, it can't be either C or D. Since the pith ball begins negative, it's going to lose electrons to the positive rod. In other words, the rod is going to absorb some of the negative charge to try to balance out. Number 8 says that there's a circuit with a current of 5 amps flowing through it. How long does it take for 30 coulombs of charge to be transferred past that point? Well, this is charge. Our current is equal to charge over time, which would be 5 equals 30 over t, or t is equal to 6 seconds. Shown are copper wires of identical cross-section. Which wire will have the least resistance? Well, it's going to be the shortest because they all have the same cross-section. So it's going to be either, it's not going to be A or C. So then remember that the hotter it is, the higher the resistance, and so the answer would be B. The circuit contains a power supply of 2 resistors as shown. What is the voltage across resistor R? So basically, if there's 12 volts total, and we've used up 4 volts, then that means there has to be 8 volts left. So number 10 should be A. And then number 11, if the resistance of a circuit is doubled and the voltage remains unchanged, the current flowing in the circuit will be, so you're using V is equal to IR, and we're keeping V the same, and we're doubling the resistance. That means the current has to go down, and it's going to go down by the same factor, so it's going to be 1/2 as much. Electrical insulators are used to resist the flow of electrons. What an insulator is, a conductor lets electrons flow, an insulator reduces the flow. The resistance of a wire is determined by the voltmeter and ammeter method. If the voltmeter reads 10 volts and the resistance is 5 ohms, find the energy consumed by that resistor in 40 seconds. Okay, so we're doing V equals IR to find the current. So we've got 10 equals I times 5, so 2 would be equal to I. So then we do power equals voltage times current to find power. That'd be 10 times 2, which would be 20. And then to find energy, we would do power equals energy over time, and we would do 20 equals energy over 40, which would be, I believe, 800 joules for the energy, which is the correct answer. What is the voltage of the power supply shown in the diagram? Well, again, if you got 5 volts in one spot and 10 volts in another spot, the total must be 15 volts, which is C, because you just would add those together because it's in series. As the temperature of a copper wire decreases, the electrical resistance would decrease as well. That's number 15. Number 16, which graph shown indicates the relationship between the resistance of a wire and its length? The resistance should go up linearly with length, which would be 16. which would make 16B. Remember the formula here is resistance equals resistivity times length divided by area. Okay, there we go. If a wire of cross-sectional area A has a resistance R, then another wire of the same material with a cross-sectional area 2A would have a resistance of R over 2, which is C. 17 is C. At room temperature, which section of copper wire has the highest resistance? So highest resistance, we want the longest, and we want the smallest cross-sectional area, which would be B. If the potential difference across a 12 ohm resistor is 4 volts, the current through that resistor is 1/3 of an amp. You're using V is equal to IR, and you do 4 equals I times 12. And solving for that, you would get 19 is 1/3. Number 20, the ratio of potential difference across a conductor to the current is called. So what you have here is voltage over current, which if you'll look at the V is equal to IR formula, if you do voltage over current, that would be the resistance. So number 20 should be B, the resistance. Number 21, which graph represents a circuit element at constant temperature that obeys Ohm's law? Well, if you're doing V is equal to IR, then R would be your slope, M, and if this was your Y and this was your X, then you would basically have a linear slope, and so it should be 21 is D. So anyway, it's basically Y is equal to MX plus B, where your Y is your voltage, and your X is your current, and your M would be the R. An electric iron draws 5 amps of current and has a resistance of 20 ohms. The amount of energy used by the iron in 40 seconds is. So again, we're going to do V is equal to IR first to find the voltage, which would be 100 volts. And then we're going to do power is equal to voltage times current to find the power, which would be 500 watts. And then we're going to do power equals energy over time, which ends up being power times time equals energy, to find the energy. And 500 times 40 is 20,000, I believe. And so 22 should be delta. Number 23, what is the approximate amount of electrical energy needed to operate a 1600 watt toaster for 60 seconds? So you would need 1600 equals energy over 60, and I believe that's 96,000 joules, but I could be wrong. Yes, it is indeed 96,000 joules. I apologize, I'm trying to feed my baby while I'm doing this, so my voice kind of goes in and out, that's why. In the diagram below, length is L, and A is the cross-sectional area. Which copper wire has the smallest resistance at room temperature? Should be C, because it's got the smallest length and biggest area. Compared to the total resistance of 2 5-ohm resistors connected in series, the total resistance of 2 5-ohm resistors connected in parallel is less, because parallel is always less if you have the same resistors. If you want to check this, it would be 10 if they were in or if they were in series, and 1/5 plus 1/5 inverted if they were in parallel, which comes out to be 5 over 2, which is 2.5. Number 26, in the diagram here shows a resistor of 5 ohms and a resistor of 10 ohms connected in parallel. What is the total resistance of the circuit? It would be 1/5 plus 1/10, which would be 3/10, but then you would have to invert it, so it'd be 10 over 3, which would be 3.33, and so the answer should be A. Number 27, the voltage drop across R1 is 8 volts, because if it's got a current of 8 amps and it's in series, you would do V equals IR for that, and you would do 1 times 8, which would be 8 volts. What is the total resistance of the circuit? that should be 3 ohms. And you could just do that by doing R1 plus R2. In the circuit diagram shown, what is the correct reading for V2? Well, we've got 110 volts total, and one is reading 20, and the other is reading 20. Then that means the other one has to be reading 70. So 27 is B, 28 is C, and 29 is B. 30. A 5 ohm and a 10 ohm resistor are connected in series. The current in the 5 ohm resistor is 2 amps. The current in the 10 ohm resistor is, well, they're connected in series, so the current should be the same, which comes out to be B. Okay? Based your answer on the following questions given the information. A 5 ohm resistor, a 20 ohm resistor, and a 24 volt source of potential difference are connected in parallel. A single ammeter is placed in the circuit to read the total current. Draw a diagram of this circuit using the symbols with labels given below. So we've got we've got a 24 volt source here. We've got a 5 ohm, and we've got a 20 ohm resistor that should connect all the way. 20 ohm, 5 ohm. And we want to put that ammeter in somewhere. Now, critically, the ammeter cannot go here or here because those are individual paths. So we have to connect it in a spot where the paths are merged, which means we could either put it here or we could put it here where those paths are merged. We just can't put it on an individual path. Okay? And that would be the thing. So if we wanted to find the total current here, you can do this you can do it 2 ways. One is to find the total resistance, which is do 1 over 20 plus 1 over 5, which would be 5/20ths or 4 ohms, because you'd invert that. And then 4 ohms, so 24 is equal to I times 4, and this would be 6 amps equals I. So you could do it by finding the resistance total, or you could find the resistance down each path. And so if I did it that way, I would do 24 divided by 5 and find this path uses 4.8 ohms, or sorry, 4.8 amps. Sorry. And this path uses 1.2, and if you add them together, look at that, you get 6 amps. So there's the review. I think I was pretty successful about doing that with the baby. He only cried once. So anyway, let me know if you need anything else, and your test will be Friday.